Hello, let me check my audio. I think we're good to go. Sounds good to me. Let's double check though. Okay, sounds good. Hello everyone, welcome to stream number 10. Yes, 10th one, made some good progress. Last time we were trying to work out why the door joining connection field stuff wasn't working. To that end, we added some more diagnostics. You can see these color boxes with the labels so we can see exactly what's going on. Got a good tip there. And what else do we do? Text label. Oh, and we split the balls so that we're looking for the opposite sides only. That's not just a general wall to door relationship. Yes, so off stream I had a quick look and dug in a little bit, and I found what the problem was. I'll show you in a sec. And I've also added a little extra things to make switching these diagnostics on and off a bit easier. So if we have a quick look now, if I move this door here, if I move it up to this wall, doink, we can see this frame that gets drawn is being drawn by this room on the left. We can see the wall is lit up, and as the door intersects, we can see it knows the right room tells the world where its door is, and the left room picks that up and draws a frame there, and it knows where that is relative to itself, which is exactly what we need. So with that information, we can split that wall off, up into parts, and how to leave a gap for the door so that it works. That's what we're going to do next. It all seems to be working properly now, and we can like move the door, and then it'll be like, oh yeah, there's the wall. We'll probably get onto some funky stuff, extra funky bits as well to help it all line up. So we'll come to that a bit later. But it's working, so there wasn't anything broken. The problem was that even though this wall doesn't have a door in, or didn't have a door in, it was still telling everyone that it did. So the visuals were right, but the actual broadcast was wrong. And that created a kind of two-way loop between the two objects, and that didn't resolve properly, and there was some lagginess, and that's why we had two frames. So I can show you where that is. If I go back to if I open up the procedures and have a look. Yeah. So what the problem was. So in our wall we have. Oh, I've tidied things up a little bit and grouped them a bit so it's easier to see. Diagnostics door query. So the doorway. So it's here. Previously, so where a doorway outputs the visuals, so you can see the door, and the fields, so that other things can know there's a door. The fields were always being generated, but I've added another switch, an if here, so that it only enables these fields when it has a door, and that fixed that. So that's good. The thing I was telling about the diagnostics, I've grouped them up here, make it tidier on the actual procedure, but they're all switched on and off by this here. So this is a sort of concept that I've used a few times, where you have a procedure that only has some numbers in it or constants in it that you can fiddle with, and they're set as an output. And in various places throughout all your procedures, you can use that information. But it gives you kind of global control over things. So if I turn this off, all the diagnostic stuff gets turned off. That's a really nice way of just unifying everything. And there's a couple of things that change here. The wall diagnostic and the door diagnostic both use this to control the diagnostics. So there's a good way of doing that. And the cost in here of having these present, there is a little bit, but for the scale of what we're doing in most projects, it's not really significant. If this could be a sub procedure with an if and the diagnostics check outside, and that would reduce it down to one single extra bit of data being carried around when it wasn't in use. So that's good. That's all working. The next step then is to look at what happens when this this wall finds there's a door in the way. So the idea is that as this sits alongside, let's line it up somewhere. Let's have a look. So it'll be something like that, where this, see the join there, lines up, and we should, in theory, be able to nicely see the door here. But as we know, the wall is being drawn as well, so we get a lot of interference. So this wall needs to split into two parts, one either side of where the door is. For now, we're only going to deal with one door. Later on, we could cope with more than one. So, for example, if it found two, that would split it into three pieces and have two doors. But there's an element of added complication that I'm not going to deal with right now, because one step at a time and all that. Yeah, right. Let us look at this wall and the data we're getting. So let's come back out here. I mean, I would leave the diagnostics on, but they're kind of in the way. I want to be able to see the pieces of door and not have the big blue box everywhere. So we'll leave them off for the minute. It's easy, as we know now, it's easy to toggle, so we can do that. So this is the editable, yeah. So this, I mean, there's an element of, so here's the bit of logic that decides, or it switches between a full wall and a wall with a doorway in. So what we could use is the same logic and just not put the door mesh in, which is fair. So we need to work out what position that needs to be. It's basically overriding the offset and the position. So I think it might be better to not interfere with, to leave this, because we might want to change that in future, and just have another path that we switch in when we know there's a door. So we do have the information about whether there are doors, and we've already got a check here to see are there doors. So in actual fact, this logic here is probably reusable. So this is has doors. Hang on, has other door. So this is like saying someone else has placed their doorway here, and I need to react to that. It's already using the diagnostics, but we actually need it up here now. So let's bring that up here. And I think the logic was going to be very similar. It's just that instead of doing all this, we do something else. Let me have a look. So based on that, so we'll need to be able to switch on our alternative wall. We also need to switch off this wall and this field. So basically this whole bit needs to be switched off as well. So we can do that. We could add more ifs out here, but it's actually probably simpler to incorporate it in the logic here. That if there is, we'll put in a sort of enable, if you like, and that can be done with the logic. Let's do, under logic we've got and, so if we bring that in here like this, so at the moment that's turned off, that hasn't affected this wall at all. Why is it not? Let's have a look. And then this one as well. In fact, they're the same because it's duplicated. They both switch at the same time, so we only need one actual check. And yeah, so by default, so this, oh yeah, that's right. This has overridden it to always do just a row with no door in. So we can suppress the door by doing that. Oh no, this isn't the right logic. We're not switching between things. Okay, that is wrong, then I can't do it here. Let's wire that back up. Yes, let's make that. So we need to be able to turn these on and off, which is a different thing. So let's do that out here. So here, yeah, so that's turned off. So this is the, so this is with door versus without. Without door versus with door. That's these two, and then this is enable. Let's say normal. Okay, now that is based on, so that wants to be turned off if we have another door. So we could put in, invert that and feed that in here. Now that is looking more like it. I'm going to do it up here. So now what's happened is it disables the wall when there's a door in the way, which is what we want, because we're going to replace it with a different wall. I mean, it'd be the same sort of procedures, but not quite the same effect. Right, so we're not going to have any fields, we're just going to have walls, so it's just visuals. It can go into here, and it'll be enabled when this is true, which we've looked at already. So what will we need? We're going to reuse, I think we should reuse this because that already does the splitting and other things. But we will need to be able to suppress the door. So let's start by copying that up here and using those visuals. So now we have our wall back with everything in it. It does have, it does have the door enabled, which we don't want because, so currently this wall would have been using the solid row without the door. Now we're using this one again. We do need to be able to suppress the doorway and then work out the position of the hole. So we're basically saying we want to be able to suppress this procedure. So we could, it's probably best just with a couple of ifs again. So if I do that for the visuals and same for the fields, we can do this. Show door. Okay, so we can do that. So now, now the doors don't show because the default is false. So back out here. Here we do want the door, so that can go back in. Everything else is probably the same. This is now our wall visual. To accommodate. Don't know. To accommodate other door. Doesn't it right? Still doesn't it right? I'll leave it. So now we have this as our doorway comes in and makes contact, it makes a gap in the wall. Next, it's in the wrong place, obviously. So we want to be able to say, based on where this frame is, I need to work out the offset. So when, let me have a look. When we get the other door, we've done it down here because we drew a frame based on the bounds. So if I can actually copy some of this stuff out. I might copy that, or because I might need to change it. So we'll bring that up here as well because we're going to use it in this calculation. Oh yeah, that might not be needed because that just makes it slightly bigger. In fact, I'm going to take that out. We might just show a frame though, just so we know where we're at. Let's show that. Oh, we want it in here, so let's merge that in. I'm just going to put a couple in and see what we get. Visuals, yes, and a frame. Okay, so you can see it's drawing a frame now. Back slightly had before, but not expanded. It shows me where the door is for this room. So we need to relate that offset along the wall to be Yeah, so really going to be comparing two frames. We've got the wall frame, which I can draw as well. Let's do that temporarily. Again, it's only going to do it on this, the one we've got it enabled. So we've got a frame here for the wall. We've got a frame here for the door. You can just see it's actually arranged the other way around, but that's fine. We can allow for that. Our wall is, starts over here. So, and it goes in Y. So it's built like this, upwards. So the wall built upwards from the bottom. This doorway is actually a frame built from the top. So we need to know, well, I guess it depends what units we had for the wall offset. So this wall, we can still use the test here, the east offset. No, sorry, this room, east offset. Yeah, so we can see, oh, it's based on off the set from the center. Okay, so we need to know where the center is. Oh, that's pretty good. So the center of this doorway relative to this room will be the offset as long as we're looking in the right axis. So we want the center of this room, that might actually just be the center position of the door frame that's passed across. We can try that and see what happens. So this bounds, there aren't any parameters actually, so we can get rid of that. We're just using the bounds of the neighboring door. So the center of that is, so this frame is in object space for this room, and we can get the position of a point in object space within a frame using an operator called framed world. So what that will do is give us, for a given frame, it will see where a point in it is in the world, and we can use the proportion. You do it proportionally within the frame. If we do a half, that will give us a point in the center, complete in every axis. We only need one axis because we want to just know how far it is in Y. It might be, I think the fact that it's the wrong way around might not matter now if we're just using the center. So let us split out that into its components and then see what happens. Right, so the door offset, which we're going to be driving here, is an integer because we are using the granularity of the component asset grid, and we got a floating point value because the room can be positioned anywhere. So this is something I mentioned in a few streams ago. It is something we're going to have to deal with. So, but we'll try it and see. I'm just going to convert it over for now. I don't think, have I got anything to round it with? Maths round. Let's do that. Let's take the Y value and round it to the nearest step. Oh, I still need to convert it to an integer. Let's take these diagnostics out of the way. Down here. Might be an idea to turn off the selection highlight for the minute, just so we can see the frames a bit better. Right, I can float to int. We can do here and hook it up. Right, so we have an offset. What does that mean? Oh, look, it does update, but it is backwards. And I think that'll be because this frame is backwards. Maybe. So I think the simplest fix is just to use the negative value, which is fine. We can do that. And we'll do that here. Simple way to negate is just to subtract from 0. And now we see it puts a gap where the door is. And if we get it, oh, the rounding is a bit rough. It doesn't need to be rounded. But there we go. We can't control how open they are. At the moment that's fixed. Where is that coming from? So it's just here. So it's just, let's set the doors to open. Okay. All right, we have a doorway which kind of lines up. Let's have a look. Let's try it. Put the ceilings back on. Got a diagnostic still. But we do have 2 connected rooms. Now we're looking for the alignment. I mean, I just aligned it up by hand. Obviously, it's not going to line up perfectly because it's not. The doorway is floating point position, and the walls, the hole is integer position. And the distance between the 2 rooms is also another factor, something we should have a look at in a minute. But that's not bad. We can make larger spaces. Makes sense for the doors to be open at the moment, so we'll leave them like that. I'm going to turn off our little bit of diagnostics here, just so we don't get the frames. And there we go. Which wall is it? Is that the east wall? No, door, sorry, it's a west door, isn't it? Yeah, we can rebuild with different door positions. I'll leave it semi-open. There we go. Right, what can we do to improve this? So there's 2 things that need to happen. Basically, the 2 different axes that everything's aligned in. Along the wall, the walls are granular, but the door position is not. So I think what we're going to have to do is make it so that the walls can be non-integer sizes. Not ideal, but might help. And the other thing, I mean, we could snap the rooms to a grid and do it that way, but which I guess we could try. That might work. And the other thing is when it's getting the walls to touch properly. I think what might be a good idea is that if a doorway contacts a wall, we work out what the gap is between the 2 rooms based on that, and expand the adjoining room a little bit. So it's basically the wall will snap to a door that's approaching it. So let's have a look at those things. First of all, let's turn these back off. First of all, what happens if we snap everything to a grid? We can do that crudely here. 1 meter grid. What does that look like? Does it actually do that? No, it does it relative to where it is now, which is annoying. And this one, let's do. Okay, so we're on a grid. It does actually. Oh wow, that does actually work. My word. Well, that's one way of doing it. Well, that's a quick fix. Obviously, it's not designed to work outside of a room, but that doesn't make any sense. Okay. Unfortunately, unfortunately, the interaction system doesn't have snap. Don't think. Did I ever do that? It's a good question. I can have a look. Let me have a look. Where's the editing for the room? It's here. Move X, Y. Entity move. Nope. No snapping. Unfortunate. Right. I'm inclined to still carry on and try and get it to work at arbitrary positions just because it makes it a little bit nicer to use, and we can use this dragging functionality. Okay, so the problem then, let's have a look at the problem. The problem is it only builds walls to this unit grid. This out a bit. So yeah, let's turn off the snap. So it knows where the frame needs to be, but it doesn't. Right. Okay. Let's go back to, instead of drawing a wall, we'll draw a box either side. We'll do our own split. In fact, it'll apply in general, but the consequence of this is it means we can position the doorway anywhere we want along a wall as well, and have the geometry rebuild to fill the space and not be limited by that snapping, the granularity. We will get some stretching and squashing, but that's just going to have to be. And the premise, I think, largely with this is that when the difference between the unscaled wall section and the actual space is going to be our scaling factor, and we can adjust, and we can still build it the same way and put scale up or down. So let's go back to working out how these wall segments work. Let's put okay, so a row of wall looks like this, and there's various logic here to do that row forward. Okay, I might wrap this so that we can keep this functionality. I'm going to call this, so this is a row, but it's also can go to any size. So to any floating point length, or is it what's it called? Unquantized. No, it fits a wall row that fits to any length. All right, for now we're still going to use row, but we are going to, and initially we are just going to show a box. So let's do that. Let's have it yellow. That's not yellow. That's yellow. Golden yellow. Right, so we've got a yellow box there. And then here, instead of these two pieces either side, we're going to use our new row fit. If I bring that in here, we'll get the yellow. And hang on, bring the seed value out so we can at least hook that up. And move that across to there. So we don't need that. What we need is another one of those for the other side. And yeah, it's the same seed for now. Okay, so now we've got, we'll see that, oh no, these are snapped as well. Okay, the snapping happens further up. Let's have a look at that next. Oh, the offset logic is here. This is done. Door offset is an integer. We are going to have to change that to be a float value, and then update this logic accordingly. So let's do that. You can't change the type of an existing input, so I am just going to add a new one. The name can be the same though. Integer offset. Okay, we'll hook that up in a sec. In fact, Let's see, door offset here. All right, so this one can actually hook up directly because we're not gonna, oh, we don't need to round it either. Let's do, let's do that. These will be redundant shortly, so we're just going to do that. Okay, so this should work for this one, because we're not rounding anymore, which means if I move this, no. Oh, we're not actually using this input yet. Right, okay. So let's, if we hook this up, and we should be able to. Right, so the logic here is we're adding it to the midpoint and taking off 5 because of the width of the door. We want to do that in all in floating point. So I need a. So let's get some maths. We need a floating point divide because we want half that. And we want to add the floating point to our offset, and then we want to subtract 5 down here. I mean, this is hard coded for the wall size, but that's fine. So now, okay, we are now working. That's better. So that's now working to any position, and obviously there's a little lag as it updates everything, but that's fine. The final rebuild will be exactly right. Okay, let me see what happens if we try and move the door. Okay, that's not working at all now. Oh yes. Yes, so the door logic has been unhooked. That's right. It's sat in the center because there's no we've broken it basically. This door offset is not being used anymore. You see it's unconnected here. In fact, I'm going to get rid of that. We don't want that anymore. That's the old door position. So now wherever that's used, we need to hook it up, which is down here. So here we've got door offset coming from editable wall. We're going to need a floating point door offset here. Oh, it's going to make a mess of all our inputs in the bit at the top level, isn't it? Where else is that used? Down here, editing. Okay, that will need to come from there too. Door offset, yeah, so that's no longer used. Basically want to disconnect everything. Where else is that used? That is there. We can disconnect that, so we'll get rid of that in a minute. So all of our doorways and anywhere else that was using that information are now not using the integer input. Still need to hook it up at this level though. So each doorway's door offset. We did. Okay, so that was this. It's all coming back. So thanks past me. I set the actual procedure inputs here to be floats, so that makes that a lot easier because I can now just move these to here and get rid of that. Where is it? That one and that one. Okay, there might be some things to fix, but we'll see. What's going on here? Oh no, that's all right. Oh, look at that. There you go. I can now drag the door. Oh, that's interesting. The TAA. So the doors now position arbitrarily. Obviously, we've still got yellow walls, but that's the next thing to fix. And that means I can move this around and it will pop in the door wherever it is. And if the door's somewhere else, it'll still work. We can build like that. Hurrah! I think that's good. Going well. Half an hour in, halfway through. Probably do an hour this time. We'll see. Okay, we now have the doors. we need to make the walls work again, because the walls are still going to be built to the to a whole number of units. Right, let's go back to, where were we? Wall with single doorway, this. So here, yeah, the fitted row here. Yeah, that's right. So if we go back to the actual row, you can see that we'll reintroduce the problem and see it's so this left one is just rebuilding to the nearest length, I think, and causing all sorts of problems as we ask it to build non-integer sizes. And this end again is having problems building to non-integer sizes, but it's building out from the wall towards the end, which is just because that's the way around the wall is. So there's a bunch of things we need to fix here. There is some shenanigans going on. I think it's a mess because the procedure was never designed to work at non-integer sizes. Fair enough. Let's see what goes on in here. Although maybe we don't care we don't actually care what goes on in here, because there's a quick fix version of this, which is that we work out the difference and the scaling factor, and then we scale everything, because there is an operator for, what's it called? Move. It's an advanced one, so it's here. Modeling move. Move geometry from one frame of reference to another, I think it says. Yes. So what we can use this for, so this applies to geometry mainly, but it does actually also work with meshes to a degree. For a simple one-dimensional scale, that will be fine. It should adjust the positioning and the scaling of each mesh as the mapping happens. So what we can do is we work out our destination is going to be what we actually want, and our from is going to be an integer scaled version, and we'll build to that. So that's pretty much a case of finding the length, rounding that size, and then resizing, which we can do with a split because we're only doing one axis. So if we get the dimensions of this bound, so we're going to work out what we can build to, because we've got an integer only wall. Let's do that. We're going to add a round function I built here. So they're built in Y. The step is going to be a unit, and we are going to split this frame in Y by that amount of units. So then we're going to build to that frame. So now we should see it whole numbers again. Yeah, it is whole numbers. I might be rounding the wrong way, but we'll see. I think it's rounding. It's not actually rounding nearest. No, it's not. Interesting. Well, we can fix that in a minute. Well, the simple fix is to add half, because we know it's a unit. It's rounding to nearest unit. I'll just do that for the minute. There you go. That means we get some overlap and underlap. Yeah, cool. So that's building the wall to the closest it can do, and we just now need to stretch it. So what I'm going to do is I'm going to use this move to move the geometry here, and the source is what it was built to, so what the wall currently is, and the destination is what we'd like it to. How about that? We now, oh interesting, that doesn't work. I have bugs in my code. What's the options here? Alignment stretch, align the source. Does that work and fix it? No, not quite. Right, this approach may not work. I think moving geometry is not exact. Interesting. That's unfortunate. Kind of works, but we get a weird additional scaling. I wonder if it's because some of these things are already scaled slightly. Yeah, that's annoying. We are going to have to dig in and have an actual proper scaling factor and then incorporate it in the logic. Or change the way the walls are built altogether, which is another option. Huh. Oh yeah, it's got the 2s and the 1s. Or we could see if we can work out what the problem is and then fix that. Interesting. Very interesting. Okay. Could be just a bug, but for now we are going to have to work around that. All right, that operator could be better. We won't use that then, which means we don't need to do that. What we're actually going to do is go in and try and fix this. Oh, I wonder if. Oh, it might be because no, we're actually. Again, slightly unfortunate because a lot of this logic is based around the actual tiles. Oh, that might not matter. Tiles along wall. Around down, yeah. Okay. Not sure if rounding down is best, but okay, so we work out, so we see how many tiles it is and we make decisions about what objects we're placing, which is fine. It's just that because these are still past the full amount, although that one shrinks it. Oh, I wonder if that's part of the problem. I think we might be better off working out a scaling factor. So if it's a scaling factor of 1, it's single units. And if it's like 1.1, it's 1.1 all the way along. And then we can apply it to some of the logic here. So for example, this shrink would be that scaling factor. Maybe it's not a scaling factor, maybe it's just the base unit size. Then we can use that to tweak, by carefully calculating at the top end, we can use that to tweak it and get it to fit properly. Let's check these other ones. Spacer, that just puts an object, that should work fine. Row 4. There's some checks here to see how close it is to certain things. Again, these values are hard coded and need to be scaled. Split 4. Yeah, that'll be scaled as well. I think we need a scaling factor or a base unit factor. So this would be scale times 4 minus a little bit. This will be scale times 2 plus a little bit. Yeah. Okay. What's the other one? Row 4 plus, what does that do? Oh, it's got a spacer again as a scaling. Right, we'll pull a scaling. This value needs to come out. What we're going to call it though, it is a scale because the base units are 1. But I think it might be better to say base unit, because if it wasn't 1 and it was 2, it would no longer be a scale, but it would still be a base unit. That makes sense, does it? Correct for that anyway. No, let's call it base unit. Right, row 4 plus row 4. Don't need to multiply here to say And then we want 4 of those. Yes, I know. It's going to break because that's now 0. Sub a little bit. Not sure exactly if that's going to be right, but it'll do. We've got a 2 and a. Hold please while I fiddle around with this. Base unit. Couple of these. That's also a base unit. That's fine. Oh, that might need to use the same logic. No, it's fine. I'll just choose a value. We're going to be close to the originals. It's just for making decisions. Row fit. Right. Let me find out where else this is used. All base unit 1. Well, that's not strictly true, but we'll do that in a minute. So we can have a little calculation procedure that takes the frame you're fitting to and generates that base unit size. Let's do that in a minute. That should be fine for that. Why is everything else broken? Where else have we got alls? Base unit. Right. 1. Still broken. Oh no. It's chugging. Oh, it's probably because it's overflowing somewhere. Row 4 plus. Spacer doesn't need anything. Oh, here we go. Row 4 plus. Base unit is not hooked up. Bang. Okay, get in there. There's one. Recursion. Okay. There we go, we're back. What's that done? Right, we've still got that. We're back to the thing where it's not actually scaling because we're not actually scaling this or changing this base unit. So where it here in the fitted one, we need to do that calculation. So let's do a little calculation helper. Calculate base unit size needed to scale to nearest reasonable granularity. So this is going to take a frame, which we're going to get the dimensions of, and then do some calculations from. This is actually going to be in Y. So the size, we're going to. So it's going to be the difference between the how many pieces we think are going to fit. Well, there's a cell utility for that, isn't there? Tile count. So we'll reuse that. So we've got a theoretical number of tiles, and that will multiply up. Yes, so right, yeah. This height, if we need to multiply that up to get the no, it's based on the units. It's going to be the actual number. So this will be this height will be the actual the actual size in units of that number of tiles fitted in. This value here, the dimensions of this bounds, is the actual size we're trying to go to. So there will be a different scaling, a different fact, and that's the two different things we're going to scale between. So it's the ratio of those will be our scaling factor, and that's a divide. So we've got our, so for example, if the actual size is bigger, like say 1.1, that would be, let's go on the numerator, the theoretical will be lower. Let's move these over the other way around. I think that's our scaling factor, or in this case, base unit. So basically, like the resize was going to go between the two frames, this is just doing it as a scaling factor to work between the theoretical and the actual size. Let's try that. Row fit. Calculation, give it the bounds, base unit. Ooh, that. That blood it only blooming works. That's nice. Obviously, if we get down to very small, it'll end up really squashed. That's just because you've laid out the room funny. You can see it starts to use, it's trying to use a single piece, which is fine. It's the smallest piece we've got, so and you end up having to squash it to fit in. But that actually works remarkably well. Great. And it should line up within reasonable. Oh, it's not lining up this way because I'm not nicely butted up. So let's do that. So yeah, there you go. We have walls that scale to any size. A consequence of this is that the we can drop the limitation that the whole room is now has to be a integer size, which means the resizing and positioning will be a lot smoother, less jerky. We won't have that problem with it stepping so badly here. In fact, it won't step at all now. What do if I fix that? Let's do that next. So that's good. The position along is good, and we will have a quick look at the position this position this way in a minute. Effectively, so we are snapping the doorway into the next room, but because nothing else, it doesn't move this way, you end up with gaps. So it might be worth trying snapping the joining wall out to meet it, which we can also do, which I think will be very neat. Given that we're rebuilding this anyway, this room, I think that would work very well, and we'll effectively be able to just snap rooms together. We could always expand this a bit so that it's a bit more sensitive, but maybe it doesn't matter. It's only when it touches that it needs to actually incorporate it. So let's do the room size as a tempted. No, we'll do the room size last if we've got time. What I want to do is get this so that it does snap. So basically what I'm saying is, in this situation here, there's no reason that this room couldn't automatically bring itself out to meet it. And that's really working out the difference between the X position of the door and the wall. Again, we can use in fact we've already got that information because we extract the center point. It's just it's not relative to the wall, I think. Yeah, so if we use the center point of the wall and the center point of the door incoming to get the X offset, we can use that to expand the room outwards. Is that going to work? I think so. As long as it doesn't cause any circular dependencies, which I don't It might end up with a circular dependency, but that's not necessarily a problem. We'll see why in a minute. Okay, let's see if we can work this out. Is it worth visualizing that at all? Let me have a look. Could do. Yeah, let's work out how much this wall needs to move outwards and draw that as a box, so we can, it basically would fill the gap. Let's see if let's do that. So that's working. Rofit works. Let's go back out. Single doorway. That's not what we're doing. It's here. So we've got all this funky calculation going on. I'm going to get rid of those for a minute. So this calculation here is working out where the other door is. So let's do that here. Other door calculation. Where is the other door? So this would also be a place to. Actually, that can stay outside. This would be the place to do that calculation because this is where we've already got the door center here. Let's call it room space. Other door center in room space, and we can get, if I just duplicate that and wire it up to the wall. This is the wall center in room space, and the difference between, well, that's there. So let's do the same as that. So this x value, if we subtract, because in what we're looking in room space at that x value, we can subtract one from the other. Might be the wrong way around. We'll see. And that should give us an amount of how different they are. It might be that it's the near side of the door, but we can probably fix that here. Maybe look at the we turn on the diagnostics, we'll better see that. So the actual door center is here. Or room center is it? We want the near side because it's only that. Actually, or is it? This wall needs to move out by the distance between its outer edge and the center of the door. Okay, so we should do this outer edge of the wall, which will be, I think the walls go inwards, so the outer edge in X will be 1, which is because we're proportional. This again we can adjust later. Let's visualize this by extending the wall a little bit and drawing it. So we take the wall, we can extend it by units in X, and it's going to extend by that much. Now let's visualize that and see what we get. Let's have green. Right, okay, we have. So if we extend it by too much, I think means we're probably on the wrong side of the wall. In fact, looking at it this way, this looks like 0 and 1 would be it's X outwards. So let's change this to 0. There we go. Now, if we move this, yeah, that's the amount there. That's the amount it needs to move out. So we can do that. You see, it's calculating basically the missing piece and the distance we need to move. Visualization for the win. So this wall needs to be able to output that value. That's for us to use up here, because this frame here needs to get bigger. Now there's a bit of a loop going on, but that's not necessarily a problem. Ooh, maybe it is. If it is a loop. Okay, that's because we're using this frame. We might need a separate input, otherwise we'll get a loop. So yeah, by loop I mean a procedure's output depending indirectly on its, a procedure's input depending indirectly on its output, and that can't be solved because that's a circular dependency. One second, I'm just I'll deal with that in a minute. Sorry, distracted by chat. I'll sort that out in a minute. Okay, we've done an hour, nearly there. Let me just try and see if I can work this out. I think the problem is that we're using this frame to calculate. Oh, actually, are we? Yes, we're using this frame to calculate the distance from that we need to extend, and then what we're going to output that. Let's do that already. So this is the difference. This is the delta. This value is going to be our amount we extend this wall by. And if we go out here, see these values here. If we use these to update this value to then rebuild the wall, then it's not going to work. So what we need to do is come back to that in a minute. This frame needs to be calculated using this extension. So for example, if this east wall says I need an extra half a meter, this needs to then be extended by half a meter before we build everything, including the east wall. What we could do is provide what we could do is provide the original bounds, the unsliced bounds, into these functions, and then they could look to see what they wanted based on which side it was and find a point. That might be simpler rather than slicing and passing it in twice. So let's do that. Let's see what that looks like. So rather than relying on this, what we're going to do is have another input, which is room bounds, and as opposed to this being wall bounds. And that room bounds, I'll move it to the top. That room bounds, we are going to rotate according to which side we're on, because that work? No, it's not a rotation. It's a little messy. Which side is that going to be the easiest thing to do? We got something for that. No, we haven't. What I need is something to take this side value, which is west, east, south, north, and do a rotation, because I can then use that to reorient this room bounds and always pick off maybe the top side to get our world position of the edge of the wall. Wall center room space. Is that right? That's not wall center. We want wall outer, which is the edge of the room basically. So, or is it? With what we need to do that, so that's going to be how's that going to be? Okay, so if side is 0, west side, it's going to be left middle, which is going to be x0, yeah, left middle, and then we rotate. Dum, dum, dum. This is all getting a bit fiddly, but it should all come through in a minute. What I need to do, I'm just going to do it like this. Have we got a select int? No. Let's do that. I'm quickly going to make another select util, int for select one of 4 ints. Just like the string one, it's going to be based around a load of ifs and some bit set checks. That and that. Like so. Quickly knocked up. Index. 1, 2, 3, and then out. Okay, that's good. In here, we're going to use the side to reorient this frame in Z and post that in here. Might need some jiggering around to get this to work properly. But if we've got I think the rotation might be anti-clockwise, so let's have a look. Side 0, no rotation, 0. Side 1, side 1 east, that's a 90 degrees, that's easy. And the south, these are just going to be a bit messy. I'm going to have to do 1 and 3 and just guess. Let's see how that looks. Okay, completely wrong, right. Okay. Have we got, is that the width of the room? Is the width of the room. I wonder if we... This is where it's not an exact science. I'm going to try that. Nope. Oh, haven't hooked it up. Okay, so each of these needs to know the room bounds. Let's hook those up. Which is going to be this one, because we're going to still, for now, use the size snapping. Let's do that. I think that these will have all defaulted to a unit cube, so it's not particularly helpful. Whatever I did here, let's go back. Let's make that back to... Here we did. And see what we've got. Oh, look at that. Right, so that works. If I've got a door on this side... Okay, that's not working. Oh, okay. Something's happening. I wonder if that is what we want. Anyway. I am going to leave that because let's just focus on this one, which is working. Oh, that stopped working. It's interesting. Oh, maybe it's because of that. Yeah, there's some other stuff to do with. Right, let's just do this side, and I think we might call it. I'll do the resize, and then we'll call it a day. Let's do that. Da, 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 da. Right, so now we can use, we have this value, and we have, in theory, broken the loop. So we should be able to use this value outside, because it shouldn't depend on, obviously that's just a visualization. We can get rid of the visualization. Well, I'll unhook it. I might need it later for diagnosing what the hell's going on. But this should only be dependent on information that is not used to build the, well, yeah, it's not, this is going to only affect the frame coming in, not anything else, so it shouldn't matter. So out here, this value, we're going to have to modify. I'm going to do a simple thing first. So what we've got is we want to be able to extend frame in 4 ways. And that might actually be a case for a little helper. Frame, it's like the shrink, but it's got to have independent amounts. So let's do that. Oh, another factor I've just thought of. If we're not doing this, we want this value to be 0. So we should also switch that here. So if it has other doors, we take this value, and if not, we return 0, because we're just not going to change that boundary. Sorry, the external size. Should I just do this as a test for now? Let us do a couple of little procedures. Extend add X. That's what I want to do. Let's just go add padding around frame different for each side. Let's do that. Frame pad. Now, the way I would do this is, interestingly, split has some interesting functionality here, because if we split with the invert and you use a negative value on the amount units and X, and use the, what that's saying is I want to split my frame into 2 pieces. The amount I'm splitting is going to be, it would normally be the beginning of the frame, and you would be left with the remainder. But with the invert option, you're saying how much of the remainder you want, and if in from the end, and if you make that negative, that's bigger, which means the original frame gets extended outside by that amount. So this setup will extend to right by amount. And let's call it east. And we can just do this 4 times, each time taking the previous frame. So this time, if I, for the left, it's a little, again, a little funky, minus X. If we don't invert, then the remainder, so the amount we're splitting is off to the outside the left, the remainder gets bigger that way. So we'll take the remainder, and then I'll do the same thing, all of this again for the, oh, hang on, these are now the wrong ones. This is west. This is going to be north, and this is going to be south. So these need to be in Y. They're chained together. The remainder is going to be our result. I'm going to just do it in and out instead. Okay, so that's each 4. I might do this west, east, south, north. There we go. That should do that, which I can apply out here. This now needs to be padded here. Now, interestingly, east padding comes from here. Is this east wall? Yes. Let's see if all that's done. Oh, look at that. Oop. Oh, oh, it actually pushes it in because it does overlap. We can get it to draw outwards. Oh my god, that's an interesting side effect. Okay, I think interesting. Yeah, that's nice. So what we should probably do there is the bounds of the wall that we're testing with, the query, shouldn't move. I am going to have to, I guess we could just offset it back. Oh, door offset. That's interesting. So that would mean this field here should offset by this amount, minus negative this amount. So if the wall is being pushed out, when it comes to build the field, it builds it back where it should. Oh no, it's not the doorway, it's the wall, which is where's that? Door here. There's this query. Oh, we can do it here. This bounds needs to be offset. Let's offset it back. It's all getting very funky. Oops, make a little space. Okay, we got one. Yep. I take this and build a, oh, hang on. Wall bounds. Hang on, I've got someone at the door. One moment. Sorry about that. Back now. Right, we've got an hour and a quarter. I was going to do a little bit more. Try it's working, and then we will call it a day. Yes, so the wall bounds, we're going to offset it back by the amount, just going to be x, I think, by this amount, but negative. Because is x. X? Yeah, probably. Let us draw this so we can check that's what's happening. Because I want to make sure that the query stays with the wall query stays. Otherwise, it'll drag it around as we saw. Show frame. Let's put that in here. And whack it in there for the minute. Oh god, we've broken everything. Wait a minute. Ah, this is not always done. Let's take that value. There we go. Right. So it's offsetting the wrong way. Okay. We don't need to negate it then. Let's drag that there. Why are we not? Oh, the frame's slightly inside. Let me resize that. Just for visualization purposes. Okay. So we can see them. Right. Here we go. That means now, so we can see this frame is not moving. It means we can break the connection more easily. It doesn't get stuck. It just snaps out when it's in range. Nice. Okay, then we don't need to visualize that anymore, but that fixes that. So this is, let's say, keep query still to void stick All right, let's go with that. So let's turn off the diagnostics. See what we've got. We can stick a doorway to another room, and it should all lovely and line up. At the moment it's only the east-west join, but in principle that's fine. Oh look, the floors don't scale. We have to do this, fix the floors. So you know I was going to make it so these weren't units anymore, these positions. Sorry, the size of the thing. It's going to be floats. We're going to have to fix the floor. We can see that happening here. It's dragging it out, but not scaling up. Okay, so the floors need to do it as well. But still, that's rather cool. We now have nicely connected rooms. Let's leave it there. That's cool. Yep, happy with that. It's a good picture. Very good. I'm happy with that. Yes. Right, that's all. Next time we'll tidy it up, and I might fix up the other 4 sides off stream, and then we can look at whatever's next. What is next? Maybe the other door type? Don't know. I think we have a play with it, build some structures, see what might be a good win. Maybe we do something funky like let's investigate how to get different skins so it's not all the same colour. Or we're going to need to fix the floor. Might have to do that on the stream. But again, it's similar. I might do it off stream and show you what the results look like, because it's a similar principle with the walls. There'll be a scaling factor just in both axes that we need to use when we're building everything out. So like a base unit in exactly the same way. We've got a smaller door we could have, so we could switch between door types. Might be quite funky. Got a few more assets to use. We could try and chuck them in. Floor and ceiling. What else could we look at? Room height? That might be a good shout. The ability to make the room taller, so the door stays on the floor level. The walls use more panels to go vertically, and obviously we have to have more panels above the door as well. And you can have rooms of different height, big bays, that sort of thing. That would be nice. Lots of ideas. We'll see next time what we can come up with. But yep, thanks for joining me. And yeah, I'll upload the video soon, so you can have a revisit it and have a look. But otherwise, yeah, cheers.